Hey, good evening, all. This is Altbeer here, and we're about to start streaming some uh, badge design stuff for the future badge that we're putting together for DEF CON 31. So we're finalizing the circuit and did some tests, and I think we got it working to where we need it to be. We did have to switch the chip we were going to use. I just didn't like working with the ESP 8266 with as many PWM pins that we were going to need. So I decided to switch to the ESP32. So that's what you see on the screen here is the ESP32 dev board. When I was pricing these out, it turned out that the chip alone, the top part here, there, to buy that alone, even in quantity from China, is like over $1.50 a chip. But to buy the whole dev board with the USB and the voltage regulator and all the other things on there, it was $3. So it was kind of a no-brainer to me. The last badge that I did, I actually had a daughter board, one of these Raspberry Pi Picos. So I'm not a stranger to using daughter boards, and I figured that is gonna make our lives easier with this badge. So everyone will get an ESP32 dev board with the badge. It looks like someone from the badge team might have joined the Discord chat. Who we got on? Maybe I can't hear you. Looks like it's Sapien. Well, Sapien, I can't hear you if you're talking.
Is that better?
Oh, yeah, that's better. Cool.
I've been on Teams all day. This was tied to a different headset.
Oh, okay. Yeah, I was just explaining about the ESP dev board. And so I worked out a little breadboarded circuit here just to test all the different things that we would need it to do, just to confirm my suspicions on if this would work well for us, and I think it will. So
I think it will too.
yeah. So I guess I'll walk through what I have here. So what I have here that's the ESP32 dev board. It's actually the ESP Room 32 model, not the D or the U. This is like the OG model, I guess. And what I hooked up here is one of the through-hole NeoPixels on this side. And I'm just hooking it up to the 3-volt power for now. When we wire it into the badge, we're going to wire these guys into their own power rail so that they're not pulling power off the ESP. But for a single one, it was good just to pull power off here for a test. And then I have the
Right.
data in for just the one data in line. Then on this side, what I have, these wires, this is one of those dual LEDs. It's a single LED housing that actually has two LEDs inside of it, and that's why it has 3 pins. So the center pin is a common cathode, and then you have the anodes for the two LEDs on either side. Similar to the blue-green ones that I used on last year's badge, but this one is red-yellow. And I figured this will work well for the flame area of the badge. So I wanted to test out one of those using PWM to
Yeah,
transition between the two colors, right? And then what I
that
have
makes sense.
here, this is my poor man's touch sensor. So I put some copper tape on here, and I cut apart a jumper cable and soldered it onto there. And then I hot glued the wire in place and made little feet so that this is not touching anything. But yeah, that's my touch sensor pad, so we can test the touch sensor stuff. So
Does it work?
well, yeah, I took all of this and I wired it up, and that's where on the screen here on the share, I worked up this little piece of code really quick. And the beautiful thing about these, where I like to keep the code accessible for the badges. That way, people don't have to know a lot of coding. That's why my past few badges have used Circuit Python, because Python is pretty easy and a lot of people know it. But this is Arduino. That's even more simple than Python in a lot of respects. So I got the Arduino code. I'm importing the Adafruit NeoPixel library for the NeoPixel.
Yep.
I'm defining some pins, like which pin is the data line for the NeoPixel, which are the two pins that are the anodes for the dual LED, and which is my touch pin. Now for PWM, I have to set my frequency, the PWM channels I'm going to use, and the resolution. I know you can do more than one LED on one channel, but I wanted to test using more than one channel. So that's why I have each of these LEDs on their own PWM channel. Resolution is just 8-bit. It can do up to 16, but with 8-bit, what that means is we get 0 to 255. That's like the common range we use when we're programming these things, so I thought that was perfect. So then I define the NeoPixel as Neo1, and I tell it there's only one pixel in this string, but on the badge it'll be more. Then I have some of the touch properties here, so I define a touch threshold. This is just a numeric value that we want the sensor to go below to sense that it was touched, right? And then I make my initial touch value, I define that as over the threshold. This will actually be overwritten as it reads the value later.
Cool.
So
I've seen that before.
Yeah, my setup, what I do is I set up the two PWM channels, so channel 0, channel 1, the frequency, the resolution. I attach the LED pins to those channels, so LED 1 is on channel 0, LED 2 is on channel 1. Then we have the initialization of the NeoPixel, and then we have our serial initialization, because I'm going to be dumping output to the serial out just for troubleshooting. So then we have our main loop. I define a delay timer for how long it's going to wait between each iteration. Then what I do here, I'm first going to iterate from 0 to 254, and that's with this I is 0 and it's less than 255 thing, and I++, standard for loop, right? And you can see this code on the screen okay, can't you? It's not too small?
No, that's good.
Okay. So yeah, the first thing that I'm going to do is I'm going to write to that PWM pin for LED 0, which is channel 0, and I'm just going to make it equal to whatever the I value is, right? So that means the first one, the first LED, is going to start at zero and get brighter, right? Now the next line here, this is the other LED, and I'm taking 255 minus I, so it's going to start high and then start to dim, right? So it's going to start at, if I is 0, it'll start at 255, which is the full brightness, and then it'll start to dim as it iterates through this. So that takes care of my regular LED. Then I just set a position value, because I'm going to modify this, so I make pause equal to I. Then if pause is less than 85, I'm going to set the NeoPixel, the color for the NeoPixel. Basically, I'm going to cycle between red and green, right? So, and that's where I'm doing some math here to automatically cycle between red and green, as long as the position's less than 85. Now, if the position, if that's not the case, but if it's between like 85 and 170, then I start shifting between red and blue on this guy. And then if it's over 170, I start shifting between green and blue. So it goes red and green, then red and blue, and then green and blue. And so it like shifts between those, the three colors, and it gives you all the different colors that the NeoPixel can do. And then I have to pipe the NeoPixel show. Then I do, this is my just iteration number where in the serial out, just to tell where it's at, I print what the iteration number is, what I is. Now here's the touch sensor. I'm going to set that touch value, which we initially set as 21, which was just 1 over the threshold. Now I'm going to make it equal to the touch read of the touch pin. Now if the touch value is less than the threshold, then that means it's been touched, and so I print touched and I give the value. If it's not less than the threshold, then I just give you the touch value. I don't say it's touched. And then I print what the value is, and then I print a new line, and then we have our delay. Now this second section is basically the same thing, but it starts counting at 255 and then goes back down to 1. So that's where everything would kind of reverse from before. And that's how we get that back and forth that I want to test the fluctuating between the colors. So that was working earlier today, but live demo gods might not be with me. We'll see if it's working now. Plug it in. Okay. And serial out. I don't know if you can see the screen down here. We have the serial monitor. It's showing the iterations, and touch equals 78 right now. And when I touch it, touch goes down to 10 or 11, and it says touched. Yeah, and so you can see that it's actually working as a touch sensor. And that
Does it matter where you touch that?
Mm-hmm. Well, the numbers change as I go along here. So down here, it's like when I touch up in here, it's like around 9 or 10. And then down here, it's more like 11 or 12. So it's not much of a difference, no.
Yeah, it's still within the threshold. That's good.
Yeah, it's still all under 20. Yep. And we can play with that threshold if we need to when we're dealing with the badge and its touch plate. It's going to have its own number based on how it lays out. So, but you can see
cool.
On this side, let me scoot it this way a little bit. You can see the NeoPixel. I know it doesn't do great with the cameras. Let me see if I can turn these lights off.
I see the NeoPixel.
Yeah, so it's pretty bright and it's throwing all the different colors. But you could also see the red and the yellow guy here going between red and yellow, and that looks really cool.
Yeah, it's very subtle compared to the NeoPixel, but it's...
Yeah, and we can adjust the brightness down on the NeoPixel, and we can also adjust the regular LED. Right now, whenever I'm playing with LEDs, I tend to use a much larger resistor than I would when I'm putting them on badges. So I think I got like a 470 ohm resistor on that guy, and really he only needs like 100 ohms, if that. So yeah, so that's probably part of the reason why the regular LED is a little dimmer. All right.
Cool.
So that is the layout that we have for the circuit. So now what that means is we have to redo the schematic to account for this size dev board. So instead of worrying about the chip and all the other components that we would put together, I just really got to do the footprint for this guy and get the schematic for this guy that has all his pins, and put that on the schematic and on the PCB. And it'll just be like the through holes for him to plug into. It becomes much easier. And it lets us focus more on the other stuff. So what I focused on here is mostly the external components that we want to interact with. There's a lot more we could do with this ESP using the wireless and using whatever else we want to build into it, that like a web server or whatever, right? We can do a lot with this guy, but none of that is dependent upon external components the way the LEDs and stuff are. So that's why I wanted to test this out first. I'm sure we can make all the other stuff work after.
I've already started working on a web server on it and a CTF for it.
Oh, nice.
So, I mean, we got to decide what the CTFs need. Well, I guess what I was thinking is I started down the typical path where you're looking for flags. Do we want them to get into where they're trying to get a web shell and then basically remote into the device, or do we
I
care?
don't know. And honestly, that is stuff that's in the back of my mind right now because what we really need to focus on is getting a hardware design done. That
Yeah.
way, if I can get this thing specced out, even before we order it, if we can get it specced out in KiCad and do like a 3D model of it, that would be awesome for like a Kickstarter launch to show people what it's going to look like, and then maybe get interest in the badge early on. So that's why I want to get that out of the way first, even if it's not 100% with the art or with the components. If we can get something out the door with that, that's why I've been so focused on the hardware and trying to get the circuit, make sure it's going to work, that type of stuff. Once we get past that, all the software stuff is easy, and we can figure that out on the fly all the way up to the last day before we throw stuff in packages, right? So
Right.
we have time for that, is I guess what I'm saying.
Makes sense.
Yeah.
So how do you see us interacting with you on the hardware part?
So
And I'm asking mainly because this is this is your domain, not my domain, right?
yeah, so I mean, now that we know it works, and that was the big if, right? We had a lot of ideas and trying to put them together and knowing it works. What I'm going to start to do is you have access to the private GitHub for this, right?
Yeah, yeah, I
Okay.
believe so.
Yeah, so I'm going to start publishing all this to GitHub, including the KiCad files. So I'm going to have the schematic hopefully done today. We'll start it on this call, and then we'll start on the PCB layout. Even though we don't really have a shape for the board yet, we can still start putting components together and worry about the edge cuts later. And when we get to that point, that's where I'll be looking for input from you guys on, hey, can we add this, or hey, should we do that? And I might need help with some of the things like batteries, right? We still have to figure out the batteries because one of the things that I realized, if you remember, I was saying the distance between the two boards was going to be the distance between a female and a male header pin, right?
Yeah, lipos are better for that.
Yeah, I was going to
But
say a AAA pack or a 9-volt pack will not fit in between this space. It's just too tall, right?
yeah,
So we could put the battery pack on the back like we traditionally do, eh, or we can look at lipos. But I really hate lipos. I got to tell you, I just really hate them. I've had bad luck with them. The one time I tried to use them, I literally blew one up trying to mess with a charge circuit. And I'll just be honest, they scare me. I don't know that I would trust myself enough to build it good enough to not hurt somebody. And I don't ever have that fear with alkaline batteries. Plus, with the lipos, you got to carry a lot of them. Remember, we're making 300 badges. Do we
yeah.
really want to travel? And I'm planning on driving to Vegas. So, do I really want to travel 18 hours in a hot vehicle across the desert to get to Vegas with 300 lipos in my luggage? I don't know that I want to do that. So, what I was looking at, I know I've traditionally done the AAA batteries. I was actually considering a 9-volt because the beauty of this dev board is his voltage in will take anything from 3.6 to 18 volts. So we
Oh wow.
can easily throw a 9-volt on there. And since it's
Yeah.
stepping it down to 3.3 for most of the stuff, that means the milliamp hours will last a little longer because the
Yeah.
step down means it uses less amperage, right?
Yep.
It's not a 1-to-1 ratio, but it does add a little. But a single 9-volt battery would be easy because then we don't even need to deal with a battery holder. We can just
Yeah.
get like the little clip that clips onto it with two wires, right? And stick that on there somewhere. And then we just have to figure out how do we get it onto the badge? Where do we put it? Now, one idea that I had on that was using a cutout. So let me see
I'm
if
just
I got.
thinking that.
Yeah. So try to get
I
my
think a
little.
cutout would be cool. Kind of blend it into the design.
Well, I'm thinking it'd be on the back, so you wouldn't see it so much, but it doesn't make it to where you have this big 9-volt battery sticking in your chest, right? So scoot you over and try to get paper. Okay, that'll work. So imagine if we have the first board and the second board, right? So one in front, one in back. What I'm thinking is if on the back board it had this cutout that was big enough that the 9-volt would fit into it, right? So from the back, you would have this hole that the 9-volt would fit into the hole. We could actually use these little Velcro dots, stick one on the back of the front board and one on the battery itself, and then just stick it in there. You know what I mean? So then the hole, if we sized it right, would allow it to sink in. It would still stick out a little, but it's not going to be like a full battery sticking out into your chest. It'll just stick out a little bit. And if the Velcro does slip, it also keeps it steady inside the thing. It's not just going to fall off and it's hanging by the wires, right? It has a place to kind of call home. As long as it's against something, it's not going to just fall out, right? So that's what I'm thinking is just like cut a hole the size of the 9-volt in the backboard, and then we'll Velcro stick it to the back of the front board so it's still, the battery's still hidden, and then the 9-volt can power this guy. You think that is doable?
Yeah. Yeah, I definitely think so. I love the idea, actually.
Yeah, and I haven't played with powering this on with a 9-volt yet because I realized today when I opened up my big Amazon box. I always have a big Amazon box. I got my 9-volt Amazon box and it's empty. So I'm like, damn it, I don't have a 9-volt battery to test this with. So I ordered some that'll be here tomorrow and I'll play with that. I have lots of the connectors. I just don't have the literal battery. So.
I'm going to duplicate the design. I actually have everything you have here.
Okay.
So, well, except the NeoPixel, to be honest. But I'll put something together to simulate it in the meantime.
Yeah. And I mean, any NeoPixel will work if you have any through-hole NeoPixels. You just have to make sure you got the pin out right when you plugged it in. Because one thing I found with the NeoPixels, the through-hole type anyway, is that they come in basically two variations, but one is just a cosmetic. So 3 variations if you consider the cosmetic. So they always put data in and data out on the outside pins. I've yet to see one that don't put data in, data out on the outside 2 pins. Now, where they differ is the middle 2 pins. On some of them, ground is next to data in, and on some of them, ground is next to data out. And because the middle pins are flipped, you have to make sure you get the pin out right or it'll fry it, right? And then the other thing, sometimes they're called reversed, and that's just where if it normally has the 4 pins in this order, you would flip it around this way. So the only real difference is where they put the notch on the plastic, and that doesn't really matter to anyone, right? So because you're physically the same pin out, right? So really it's just the 2 ways of doing it. Now what I was thinking for that, to make our badge universal, even though we're providing the NeoPixels, I always had an issue with not having the right NeoPixel later to add to a badge that was designed with a certain type. So I was thinking, I get my paper back here, on the footprint of the NeoPixel, right? So where you normally have the 4 pins, right? And let's say this is D in and D out. And then this would be ground and VCC, right? We could actually put 6 through holes here, right? and flip VCC and ground. And then we could put some silk screen around that with just like a line through it and an asterisk to see a special note. Like, don't use those if you're using the LEDs we're giving you. So this will be laid out the way we want it to be for our LEDs. Yeah. But the other through holes are there so that if somebody wants to use a different LED, they just wouldn't use these two. They would bend the pins out a little bit and just plug them to the other two. So they're not crossing pins or any craziness like that. And this way it would work with any of the through-hole NeoPixels just by having that middle two pins flipped like that on the board. So we could easily do that. It'd be just a couple extra holes on each of the NeoPixels.
Yeah, that's cool.
Yeah. So that was something I was thinking about, and I'm glad I wrote it down because otherwise I'll forget about it. All right. So that being done, and we got the code working good. So let's actually unplug this guy before I knock it out.
What do you do for the design? Are you using like Fritzing or anything like that, or?
I use KiCad for the schematic and the PCB. Yep. That's actually what I was about to open. I hear lots of beeps. We have other people join?
Yeah, there's 4 total, including you and me.
Okay.
There's me, Bounty Lover, and someone named With Logic.
Ah, With Logic. Good to have you. All right, so we don't need you anymore. All right, so you can probably see my screen if you're looking at the stream. I got KiCad 6 open with our project. And so the schematic is where we left it last time, and I know we were planning on the 8266 for that. But one thing I think I noticed was I didn't see a good schematic that I liked for the ESP32 in the symbol editor. So let me just take a look at this. ESP. Yeah, these are all based on the chip. But yeah, I really don't like the way they laid these out where all the pins are on one side. Why the hell would you do that?
That's not accurate.
Yeah. This is not good. Yeah, so I was thinking I'll put together my own.
We're using the W Room 32, right?
Yeah, but the schematic, I mean, it doesn't matter on a schematic. It's not supposed to match up exactly to the physical layout, right? But I just really don't like that they put all the IOs on one side of this thing.
Yeah.
I guess for now this will work. So let me copy this. So save as. And then anyone who's seen my stuff online knows I save everything locally. So I have, let me save this. So save, good. What I have is, let me pull up my thing. I put together the local footprint library, which is part of the Git repo for this, that has these directories. So I have, this one is just like my Altbeer logo. This one is all the local files. This one is some organization files. And then I had a Raspberry Pi one that I kept separate for some reason. I don't know why. And then I have the schematics. So the schematic is the same way. It's just all the little things are inside of one big file. So I have local, Raspberry Pi. And what this allows me to do by making copies of anything, even if it's in the KiCad main library, not everyone will have all of the footprints, right? So I went and downloaded like the 2 gig package from the KiCad GitHub that has all of their schematics and all of their footprints. Not everyone's going to have that. But if they want to modify one of the things I'm using, I want to make sure they have it. So that's why adding these local libraries allows you to do that. And what you do is, under Manage Symbol Libraries, you can tell it what project specific libraries you have, and that's where it does the lookup from that. And same thing with the footprints. So whenever I put together a project, I always save all of the symbols and all of the footprints locally, and I also try to save all of the 3D models locally as well, because I like to put together 3D models of the boards that we put together. So that's just good note for anyone else building projects like this. That's very helpful, especially if you get people upgrading from KiCad 5 to 6 or 6 to 7. I guess 7's out now. A lot of times they change the names of things and you don't know where the new thing is. So this makes it easy. It's all put together. All right, so let's go to our schematic editor. All right, so we need to get rid of this guy. And then okay, so some of these notes we had, we're not going to need test pins to flash the MCU anymore because we're using a dev board. USB choice, we don't need one. It's going to have a USB on board. Voltage regulator, don't need it. Yeah, capacitors we still need. Battery choice, I think we're going to go with 9 volt, but we'll still leave that as a question mark there. All right, so we have our guy here. And so we were talking about like 4 NeoPixels, 2 for the flame area and 2 for the lightning area. And then for these guys, we were talking about 6 LEDs originally for the flame area, but I don't think we need that many because we're using the duals, and actually the duals would actually look like separate LEDs here. I think I have a dually, don't I? Let me look at my symbol editor.
So you're thinking 4 maybe instead of the 6?
Yeah, that's what I was thinking, but it's actually going to be 8 then, because 4 of those is actually 8, right?
Right.
Yeah.
Yeah, it's more compact though, and it gives
There
more
it is.
room for controlling the brightness.
Yeah, so that's the one we need for that. So that's our 2-color one there. So let's get rid of these. Okay, so we're going to have 1, 2, 3, 4 of those guys, and 2 of those. So that gives us a total of 6 LED, or a total of 8 of these, but in 4 packages and 2 of these. That's all for the flames, right? Now for this section here, get rid of these 2, because I think what I ended up buying for this is I bought blue LEDs and I bought bright white LEDs. And so we will have like 4 blue that are just blue and 2 that are just white, and then these 2, and that should be good for the lightning effect, right? At least that's what I hope. So yeah, that's quite a bit of LEDs for one package.
Yeah.
And then what I'll probably do, just to keep the strips separate, we'll have these 2 will be connected together in 1 strip for the flames, and these 2 will be connected together in 1 strip for the lightning, so we can call those Neo strips separately. So I'm just adding up here. So that would be 1 data line, 2 data lines, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15. That's 16 GPIOs that we need just for that. and then we need one for the touch. So that'll be 17. So I think we have enough. And that was another thing I was looking at. Let's pull this up. So I think I put it under docs.
I counted 15.
Yeah, but not all of them are safe to use. And that was where I got this guy. Let's pull this up. So, try to make that bigger. What this guy does is it's just showing you which of these pins are absolutely safe to use. They're not used by anything else internally, right? The ones that are red, you shouldn't use because they're used for flashing the board, right? The ones that are in yellow might be used by other things internally, like the Wi-Fi. I forget which ones on here control Wi-Fi, but if you're using the Wi-Fi, it means you can't use those pins, right? So rather than try to figure out which pins are safe or not, I just looked up a guide where somebody actually already figured that out. And what do we got?
That's
1,
cool.
2, 3, 4, 5, 6, 7, 8,
15,
9,
right?
10, 11, 12, 13, 14, 15. Yeah, so we might have to use 2 of the yellow ones to get to our 17. But that...
I counted 15 though.
Yeah, but we need 17.
No, count it again.
Over here?
I mean, or maybe I'm missing
All right,
something.
so let's see. These 2 NeoPixels, that'll be 1 data line, right? So there's 1. These 2 is 2, right? Then we got 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, and 1 for the touch is 17.
Okay.
Right?
Yeah, that makes sense.
Yeah. So we have 15 that we know are absolutely safe to use, and some of these yellow ones we can dig into the manual to figure out why they made them yellow. And if it's stuff we're not worried about, we can find 2 of those to use. That's not a big deal.
Okay.
And then that gives us all the pins we need.
I put my money on D15 and D2.
Yeah, those will probably be okay. So, all right. So, yeah, my OCD is just not going to let me use this. I'm looking at it and I'm just like, no. I'm going to take the time and actually do a new schematic for this that actually has stuff on both sides of this box, because otherwise it's just going to bug the shit out of me. And I know it's illogical. This is actually a good layout of it has all the stuff accurately on here, but I just can't work with that.
I like it to map physically too.
Yeah, sometimes I do that where I'll try to make it look physically correct, but honestly, sometimes that is more confusing. So I'll have to take a look at the chip and see if it makes sense to lay it out the way it is physically. But if you have a lot of stuff jumping all around, like I think there's more than one ground pin, stuff like that, it might not make sense to do a physical layout. So I'll take the time and do that a little later. But yeah, let's save what we got, and then I'll work on that a little later. So we'll get that schematic done in the next day or so. And then I think I found a good footprint. I didn't have a chance to look at it. I just uploaded it. Let's look at the footprint editor, but I think this will work. I copied it local already. Yeah, so I found this guy, and I think this was if you were actually going to be mounting it, right? Because it has the drill holes for the mounting, which we don't need, and it has this copper area here, which we don't need. So what I did was I made a copy of it, and I just nuked that stuff. So, because really all we need...
What's the copper area for?
I think because that's like underneath the antenna, maybe. Because if you look at the fab diagram here, this is where the USB would be, I think. Yeah, I think that's the way that lays out. And so then that would mean this is where the antenna is, right? So maybe they put a copper area there to be under the antenna for some reason, like for shielding maybe. I don't know. So I'll have to look into this to see why that's there. Maybe that makes sense and we keep that. But I definitely know we don't need the drill holes because we're not drilling it in. We're going to solder it into the board, right? So yeah, I took that stuff away on this one. And I'll do some measurements here just to make sure it's precise. Because I just got this off a random site on the internet and I don't trust until I measure. So, but if it measures out properly, then yeah, this will be perfect. Yep. And I do that for all of the things. So like that LED, the 2-color LED, I made my own footprint for that one for the homecoming. Let me see, where was that? It'd be LED 3mm 2, no. It's somewhere here. I might have named it something different. Yeah, but I do a lot of my own footprints. Sometimes I'll start with somebody else's and then make it for my own. You can see a lot of the artwork I did for the last badge in here.
Nice.
Yeah, it's somewhere in there. All right, but I think that is good for that. So I will finish up some work on the schematic by tomorrow. I'll post what I have so far, so you'll have those schematics and footprints in there. But yeah, and I have in the repo is this docs directory. It has all of the data sheet that I found plus all of the different diagrams. So in addition to like the full pinout, why does it keep opening on this other screen? There we go. So I have the full pinout. Let's say like your standard shows everything all at once. I have breakouts where it shows just the GPIOs, which ones are GPIOs and which ones are input only, because that's the other thing is some of these GPIOs, you can't use them as outputs. That's why some of these are yellow. I remember now. Yeah, so these guys won't work for us at all because those are input only.
What about the touch, the capacitor?
That's the other thing is the touch pins.
Touch.
There's a bunch of them. I was flabbergasted. I didn't know it had this many. It has 10 touch pins, 0 through 9. We're only going to need one of those.
There's D15 and D2.
Oh yeah, those two are touch. Yep.
And there's one. We just need to find one more.
Yeah, and then some of these are analog to digital. Some of these are digital to analog. And then the PWM shows you which ones have the PWM. So that'll tell us which ones will be good for using on the PWM, and it has quite a few of those, right?
Yeah.
Mm-hmm.
There's quite a few.
Yeah. So I was able to get quite a bit of data. That'll be helpful, and that'll all be in the Git repo under the docs directory, and then the KiCad stuff is all under EDA. Reference parts you won't see because that's a sub repository. And honestly, I don't think we need anything out of there yet, although I have been ordering a bunch of stuff that is referenced in the reference docs. So like the little 3mm 3 position or a 3-hole, not 3-hole, it's a through-hole switch, the on-off switch. The same one that I used on the last badge. I ordered a bunch of those for this badge. Because I want to have a nice on-off switch for the battery, especially if we're dealing with Velcro to put the battery in there. You don't want people having to unhook the battery if they go to plug in the USB, right? It's easier to have just an on-off switch. You turn it off, and now it's on USB power when you plug USB in. What else did I order?
would it short circuit if you have both of them on, the 9 volts and the power supply at the same time?
It would not short circuit. What it would do is double the voltage. So it's going to be powering it from two different inputs. So depending upon how they did the circuit on the dev board, it might have some protection for that, but I don't want to rely on that. I want to, because I think they do have some protections on if it's taking voltage in, and it's also taking USB power. They have a voltage regulator there that can take in up to 18 volts. So what's going to happen is we're going to have the 5 volt and the 9 volt are going to combine to be 14 volts. So it would probably work, but why take a risk and hope that it works, and when I could just put it on off switch there that most people know to use.
YOLO.
Yep. All right.
YOLO. YOLO. Just kidding.
You gotta find a way to make a magic smoke appear somehow, right?
That's not usually a good thing. I also have the code in here, the Arduino code that I've been using. So I started my very first test was very simple, blinking the onboard LED. And then I went with the NeoPixel, then the PWM, and then I combined NeoPixel and PWM. And then the last one is the one I was just showing you with the touch and the NeoPixel and the PWM. So yeah, you can look at all the code for that in the GitHub once I do the publish on that. Yeah, and then art, I need a lot more work done on art. I haven't been focusing on that. Been focusing on the hardware so far. All right, so
Do you use KiCad for the art too?
No, I use, well, yes and no. I use Adobe Illustrator to do the art as vector art. And then what I do is I save those, I export those as, I think it's DXF is the format. And then in KiCad, I can import the DXF files as footprints. So that's where I was showing in the footprint editor. You saw some of the art that I did for my other badge that I didn't purge from this one yet. So like, let's see the 30, or here, the flowers. Yeah, we'll look at that. Yeah, so you see the flowers here? This was art that I used on the badge. And what I did was in the footprint editor here, I just created a new footprint. And then I did file, import graphics, and it tells you the different formats that it'll support in another screen. But you give it the file name DXF right there. So you give it the file name, and then you can tell it where to center the placement, and then you can scale it as well. So scaling is the big issue when you're dealing with vector art and bringing it in. So I have certain settings I use, and I don't recall off the top of my head what they are. But basically, these settings allow me to keep an import scale of 1.0 on here, because I'm exporting it with the right scaling to where I think it's like, it's when you save the DXF file, it tells you how many millimeters per pixel or something like that is one of those settings, and I forget now, but I got it saved somewhere for when I do that. But basically, if you get that value right when you're exporting it from Illustrator, then you can just import this with an import scale of 1, and it'll turn out like this. Now, one thing to note when you're doing this, Illustrator, when you're dealing with vector art, allows you to do this thing called filled areas, right? Where as you're drawing, you can actually fill an area, and I could just draw this outline of this flower here, right? And it would fill that, right? That doesn't work with DXF. If I was to import that, you would just see the outline. You wouldn't see the filling. So in order to get filled areas like this, you actually have to do many lines to fill it in manually, line by line, in Illustrator. And so every one of these filled areas is multiple lines drawing. So that is the downside of that. But I think the art imports beautifully doing it. So I'm willing to do away with filled areas and fill them in manually to get that quality. So And
That's
then
helpful.
once it's a footprint, when you're importing the graphic, you notice all the layers here on the right. It doesn't have to be a silkscreen layer. So I can import it on a copper layer, and that's what we're going to do for the DeLorean body. I'm going to do that art as a copper layer so that it'll be the touch, right? And then that'll also be, I'll import it again as, or I'll make a copy of it as the solder mask layer, because the solder mask layer, instead of adding something, you're telling it to remove something from there, right? So normally the solder mask is the color, right? So looking at like this badge where it's purple, that purple is not the actual color of the PCB. That's the paint, the solder mask that they put on there. And so if you want it to be clear in an area, you do a solder mask void, they call it. And you would have to do it on both sides for it to be a window. And that's what we're going to do for the areas in the flames and in the lightning that we want to basically shine through the LED light. We're going to do the solder mask voids in those areas of the artwork. That way it'll be like a little window. It's going to be more diffused than a window because the actual PCB color is kind of yellowish. It's not like a clear color. Although I did see they had clear PCBs now, but they're super expensive. When those come down in price, I might play with those. But yeah, tangent. The regular PCBs are kind of yellowish in color, so if you do that void, it acts kind of like a diffuser, like a natural diffuser through it without having to put something over the LEDs. So what I'm hoping the effect is, and we probably won't know till we get the first dev board, is that we're going to have all these bright LEDs, and instead of them being in your face bright, it's just going to be nice dull lighting effects that are flickering and stuff, flickering flames or flickering lightning, right? And then the outside rim, because I plan on making the back badge slightly larger than the front badge, and on the edges of the back PCB, I'm going to do exposed copper there using the solder, using a copper layer and then exposing the solder mask. So it's kind of reflective. So what we're going to get is the light coming out the sides between the two badges will reflect off that, and it should be a cool glowy effect around it. At least that's my hope. I don't know how well that's going to work, but we're going to try it.
That's cool.
Yep. All right.
I look forward to that.
Next steps. So I think last time we talked next steps, I took notes. Okay, so USB connector, that's done. We don't need that no more. Voltage regulator, don't need that no more. SSID on ESP. Someone was going to do a quick write-up on how to set up the Wi-Fi on ESP, because I've not done that before, and one of you guys said you did. Doesn't have to War and Peace, just something for me to figure out how to set it up.
I'll add that. I kind of did it to figure out the web server piece.
Okay.
But yeah, I'll share.
Yeah,
that.
and that's you have the
tomorrow.
web server too. Then cool website on the ESP. All right, and then the crypto challenge. That's still kind of all of us, but that is for later. Capacitive touch we got done. So. And then concepts for other cool stuff. So we have 4 things on here right now. What else do we need to be focused on? Let me think. We know we got to finish the hardware. So that's our number 1 priority is to finish the circuit. So
write it down.
and then number 2, a mock layout. Doesn't have to be accurate. It's just for 3 views for Kickstarter. And then our third priority is starting something on Kickstarter to let people know this is what we're working on, this is what we're going to do. And I think for number 3, we need to start talking about what do we need for Kickstarter? Like, what is the required elements? I know we have to have a launch date. We have to give them like a target dollar amount, I think, but I've never done that, so.
So I started looking at that. Bounced to the question of the launch date.
Yeah.
I'll make a note of all the other things we need. Launch date is kind of like the most critical piece.
Okay.
The rest of it is more we decide what it should be.
Yeah.
Such as the amounts, how many we're going to offer, the thresholds as far as, early people. So I'll make notes of that. I'll probably kind of set up a template where I'll say, I'll make something up just to make it easier for us to go through it, and then we say yay or nay and adjust it in such a way.
Okay. Then let me look at a calendar here. So it is the 11th of May. When is DEF CON? So that's right, I marked it on the calendar. So DEF CON is like the 10th through the 13th. Well, really the 9th, because LineCon starts on the 9th. A week before that, on August 2nd, is DHA. So Dallas Hackers Association meets that Wednesday, which is perfect. Because what I would like to do as far as distribution, because that's the other thing with the Kickstarter is, I should pull this over here. So the other thing with the Kickstarter is I want to set the distribution times and places as part of the Kickstarter, because we're not going to mail these things. People will have to show up at one of the times and places to get their paid for badge, or it will be considered a donation to a starving hacker after the last distribution. They'll be able to show up at any of them, but after the last distribution, you haven't picked it up, it's a donation. So we're going to start our very first pass out of the paid for items would be on August 2nd at DHA. We might do another one after DHA, like that week, maybe over the weekend. I would set up like at some bar someplace locally for people that can't come to DHA, maybe someplace a little further north. But then Wednesday in LineCon, I want to do one of the distributions actually in the line at LineCon. I think that would be badass. And then we can have other times and dates throughout DEF CON, right? So that's kind of our target for giving out product, right? So if we work back from then, so a month before that, July 5th, a month before that, June 7th, right? And June 7th is also a DHA. I'm thinking June 7th is our drop dead date to launch the Kickstarter, meaning if we can launch it before then, that might be good, but June 7th is the absolute last day we can launch a Kickstarter to have it be successful, because that's only 2 months before our first pass out, right?
Yeah, that's fair.
All right, so that's our target launch date then, is June 7th.
Okay. So I'll start putting a schedule together,
okay,
and kind of a marketing plan as well.
Awesome. And it'd be cool if we can make the launch time coordinate with DHA to where we can actually launch the Kickstarter from a DHA meeting. That would be kind of badass.
That would be cool.
Yeah. All right. And so that means, we have, less than 1 day, less than a month between now and launching. Doesn't give us a lot of time. That's why I'm focused on the hardware, to get at least some demo information, like the 3D models and more info. And then these streams, we can link the YouTube channel to the Kickstarter, right? Oh, excuse me. That way people can actually see the thing getting built as it progresses. I think people like that.
Right. So who's got Illustrator on the call?
Well, I do, obviously.
Right. Yeah, I don't have it.
Yeah.
Uh,
Yeah, and I don't know that I need that much help with the art because the art is something I can usually crank out pretty quickly. My problem is I get distracted easily by like I got the new ESP things in it. Ooh, shiny thing! I got to work on this, right? I need to find time to actually dedicate to the art, and then I can knock it out pretty quickly. So that's why I'm thinking once I get past this the hardware, I might do a little more focus on the art to make the 3D model that we put together look nice for the Kickstarter. But yeah, the illustrators only really for the art and the layers like that. I think, like I said, where I'm going to need help is more in the ideas as we go to lay things out, and the ideas of how are we going to place the 9 volt in there? What do we need to do to hold this together? How does that look when we start 3D modeling it? Just to get more input on that, so it's not just all me guesstimating and and moving forward with a hope and a prayer. Yeah, because I don't think we need anything else with that. Now, as far as the circuit goes, just breadboarding out the circuit, you said you had a lot of components. Maybe I will mail you some of the NeoPixels I'm using and some of the little dually LEDs that I have. Because what I'd like you to do, Sapien, if you have the breadboards and the components, is actually, once I get the schematic done and I can pass that on to you, actually breadboard out the whole circuit, like with a something for a touchpad. It can be a piece of foil. It doesn't have to be fancy like the one I made. Breadboard out the whole circuit, all the LEDs, all the NeoPixels, and the touch. And we have to see how that operates power-wise, because I'm concerned about overloading the ESP power output. Now, I know if we take the NeoPixels and put them on their own power rail, it's probably going to be fine, but I just want to make sure that if we're throwing all of these LEDs at full brightness, it's not going to go beyond the maximum power output this guy can do on the 3.3 rail he has. So, make sense?
yeah, I can meet you somewhere to
Okay.
expedite it too.
Yeah, yeah. We can touch base when we get off this call and figure something out.
Yeah. Yep.
Yeah, because I got lots of parts and I got more coming in all the time.
Yeah, I have everything except the NeoPixels.
Yeah.
So.
Cool.
And those particular LEDs that you have.
Yeah. All right. Anything else?
No, I honestly, I'm glad that we covered a lot of these topics. It really presents a good picture of what we got ahead of us, and I agree with you. We need to truck along.
Yeah. Yeah, and I think making the call for going with the ESP32 dev board, that made our lives easier, but that just puts the pressure on us more to get everything else done now. Because all the hard work's been done that we were trying to figure out what voltage regulator to use and what USB connector to use. All that's done now. We can move beyond that. When you're putting stuff together, if you want to for your touch panel, I have a reel of this stuff. It is solid copper, and it has a sticky back. So you peel the paper off of it, and the sticky stuff is right on the copper. So it works great for doing little things like this. So I can peel some of this off for you and cut it off when I give you the NeoPixels.
Yeah, that's cool. See, we're getting all fancy now. This is cool.
Yeah. And what's funny is this solid copper stuff, that wasn't even what I meant to order. I was trying to order something else. I don't even remember what the original thing was I was trying to order. And it just came. And I'm like, what is this? Oh, it's that thing I ordered. So yeah, it was a mistake, but it was a good mistake. So
It is.
cool. All right, well, gents, I think that's all we have for this session. So if nobody has anything else, I think we will go ahead and call this one a wrap, and then we'll follow up online. And Sapient, I'll touch base with you on how to get you the stuff. Maybe this weekend we can hook up and I'll get you some supplies for you to start breadboarding some stuff out.
Sure.
Cool.
It's good.
All right, and for people on the stream, thank you for watching us through the design process. You're getting the inside view to how these badges get built. Well, at least how I build them. Maybe other badge teams are a little more organized than we are, but yeah, you have a visibility into our shit show. So enjoy, and we will talk to you next week.